Here we are going to solve a problem based on force analysis and circular motion. We have been given a small aircraft. It is flying currently at a speed of 450 kilometers per hour, and it is making an angle of 40 degrees with the horizontal, and that is because it is trying to take a turn in a horizontal circle, and we have to find the radius r of that circle or the curve it is taking, assuming that the aerodynamic lift provided by its wings and its own weight are the only two forces acting on the aircraft. Let us now think through this problem and come up with a strategy for solving it. So first we think of what are the forces that fly the plane, and by that I mean that forces that keep it afloat and help it take a turn. See, there are only two forces. One is gravity, and that is bent on bringing the plane down, so that can't keep it afloat. That leaves us only with the lift. So that must be the force that flies the plane, so counterbalances its weight and also provides the centripetal force necessary for taking a turn. Okay, so we have figured out the roles of the forces on the plane. Now let us think of what is the best way of resolving them. If you consider the main forces, the weight and the centripetal force, then they are horizontal and vertical in direction, and therefore those are the good directions for resolving our forces. So we are all set for drawing our free body diagram. Free body diagram, as you know, is just the body isolated along with all the forces coming from other bodies. So here is our plane, and these are the two forces acting on it, the lift L, which is always normal to the wings, and the weight, which is always vertically downward. Now, as we decided earlier, we are going to resolve forces in the vertical and horizontal direction. The plane is making an angle of 40 degrees. Let's call it, say, theta. So that is the angle made with the vertical by this lift, and we get two components, L cos theta and L sin theta. Now this L cos theta must be balancing the weight and keeping the plane in a horizontal plane, and the L sin theta component is pointing in the horizontal direction towards the axis of rotation here, and therefore that must be the centripetal force. So we can equate the vertical forces, L cos theta, to be equal to the weight mg, and secondly L sin theta, the horizontal component, will be mv square upon r, the centripetal force. Then we are going to combine these two equations 1 and 2 and eliminate this L here, and just by dividing these two equations we get cot theta is equal to g into r, where r is the radius, upon v square. Then we can just transfer some terms and keep our unknown that we are looking for, the radius, on one side, and then just make substitutions. So numerical calculations can proceed now. Before we do that, be careful and make all the given quantities into same system of units. V is 450 kilometers per hour. So multiply by 1000 to make it meters and divide by 3600 to make it per second. So that's how we get 125 meters per second. And then it is just a matter of substituting into this expression and calculating the radius of curvature of the turn the plane is taking. It turns out to be 1900 meters.